practice questions from our Solving Cubics notes. Now, I managed to find a bit of time to do just this, so we're going to run through this pretty quickly because I don't actually have tons of time. But I do think it's going to be important that you have both an answer key and also a video to check solution since I won't be around. All right, so for question 1a, we're asked to use the rational roots theorem to find and list all the possible rational roots of a polynomial. All right, so for this polynomial, we have coefficient of 1 here, and that's a leading coefficient. So leading coefficient, which is corresponding to our n value, is 1. So the factors are plus or minus 1. Pretty simple. All right. And the constant term, which corresponds to our m value, is 6. And the factors of 6 are plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. Now, so for all possible rational roots, we're going to list all of our m values, m factors over all of our n factors. So I'm going to start with 1 here for my m factor, so it could be 1 over 1, which is really just 1, or 1 over negative 1, which is negative 1, so I could say plus or minus 1. I could do 2 over 1, or negative 2 over 1, 3 over 1, or negative 3 over 1, 6 over 1, or negative 6 over 1. So these are all the possible roots. All right, so hopefully question B gives us a bit more of a challenge. So B, our n value factors are, so n is 2, so our factors are plus or minus 1, plus or minus 2. Our m value is 3, and that means our factors are plus or minus 1 and plus or minus 3. So for m over n, we could take any of these guys and put them over any of those guys. So 1 over 1, so we get that's 1. 1 over 2, plus or minus 1/2. 3 over 1 is plus or minus 3. 3 over 2, we get plus or minus 3 over 2. As simple as that. Question C. All right, again, we have prime leading coefficient, 3, and a constant term, 5. So that means our n value is 3, so our factors are plus or minus 1 and plus or minus 3. And our m value is 5. Our last term is 5. Oops. So factors are plus or minus 1 and plus or minus 5. So we're going to find our m over n values. N is good first term because it's like a numerator. All right, and so we're going to get 1 over 1 or 1 over 3, plus or minus 1, plus or minus 1/3, pardon me, or 5 over 1, and 5/3. All right, and lastly we got question D. So our leading coefficient is 4, and the factors of 4 are plus or minus 1, plus or minus 2, or plus or minus 4. And our m value is negative 3. And our factors are plus or minus 1, plus or minus 3. So if we find all of our possible rational roots of that polynomial, they would be plus or minus 1 over 1, which is 1, plus or minus 1 over 2, which is 1/2, plus or minus 1 over 4, plus or minus 3 over 1, plus or minus 3 halves, and plus or minus 3 quarters. Oops. Okay. So this question, question 2, is nice and straightforward. It says, use the rational roots theorem to answer if x plus 1 is a factor of this thing. Well, let's start by listing all the rational roots. The possible rational roots. All right, so that's going to be, we've got a plus or minus 1 for our n value. So we've got plus or minus. So we're going to have these guys, which are factors of 12, are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, oh god, plus or minus 6, and plus or minus 12. That's these guys here. And this guy's factors are plus or minus 1. These are our n values and our m values. So all the possible rational roots are all these numbers over this guy. So all the possible rational roots are plus or minus 1 over 1, or 1, plus or minus 2 over 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12. Oops. Pardon me, I didn't realize I was writing off the screen. All apologies. All right, so these are all our possible roots here. Those are our possible roots that are rational, at least. There may be irrational roots as well. All right, and so do any of these correspond to meet with a factor of x minus 1? Yeah. Yeah, they do. Huh. And so it turns out that 1 is one of the possible roots. Positive 1 is a possible rational root. Therefore, x minus 1 is a potential factor of this isn't meant to say use the rational roots theorem to answer this. It's meant to say use the factor theorem to answer this. So this is a potential factor of x cubed minus 2x squared minus 11x plus 12. However, it should actually say use the factor theorem. That's the following. Is x minus 1 a factor? Well, to know that, we have to put in, we have to say, well, p of x is equal to x cubed minus 2x squared minus 11x plus 12, and we're going to put in the root that corresponds, p of 1. And we're going to say it's 1 cubed, which is 1, take away 2, minus 11 plus 12. Wait, hang on, I think that works. 1 plus 12 is 13, negative 13, that equals 0. So yes, x minus 1 is a factor. All right. So that's question A. Question B, we're just going to use a factor theorem here. So we're going to say, we're going to find p of negative 3 here, because the root of x plus 3, the root is negative 3. So we're going to plug in negative 3 here. 2 times negative 3 cubed, which is negative 27, minus negative 3 squared is 9. And we're going to get plus 54, because 3 18s is 54. And we're taking 2 negatives, making positive, plus 9. Now the negative 9 and the positive 9 cancel out, so we get negative 54 plus 54. That's equal to 0. So yes, x plus 3 is a factor. Moving on. Question C. Okay, so we're going to try So the root for 2x minus 1 is a half. So we're going to try a half in here. So into this polynomial. So that's 2 times a half cubed plus 3 times a half squared minus 8 times a half minus 12, which is that's 2 half times a half times a half is an eighth, but 2/8 is a quarter, plus 3/4 minus 4. Wait, hang on. Half of 8 is 4 minus 12. So it looks like these guys are going to add to 1, but we're going to take away. So well, all I care about is not equal to 0. Therefore, 2x minus 1 is not a factor. All right, let's move on to question D. So question D, the last one here, with 2x plus 3, is that a factor? I don't really want to plug that in. All right, well, I will. All right, so we're going to try p of negative 3/2 and say, okay, well, that means we're going to get 4 times negative 3/2 cubed plus 12 times negative 3/2 squared plus 3/2, which is like minus a negative, minus 15. All right, and so this is going to suck. Okay, this is 4 times, this is going to be a negative 27 over 8 plus 12 times 9/4 plus 3/2 minus 15. All right, so, God, this is ugly. All right, so 4 over 8, so that simplifies to 1 over 2. So it's really negative 27/2 plus, you can divide this by 4, 1, 4, 3, plus 27 plus 3/2 minus 15. Okay, so wait, negative 27 plus 3 is 24/2. So these guys together make 24/2, which is negative 24/2, which is negative 12, plus 27 minus 15. Hey, that works. 0. Therefore, 2x plus 3 is a factor. Nice. All right. Question 3 says, determine the value of, or values of b such that x minus 5 is a factor of this stuff. All right. So if, let's write this. X minus 5 is a factor of x cubed plus bx, weird, minus 18x plus 40, then, and we'll let that, call that p of x, then p of 5, which is equal to 5 cubed plus b times 5 minus 18 times 5 plus 40 should all equal 0, right? And then we have a one variable equation we can solve. So let's just find the value of b that makes this all true. This is 125, 5 cubed, plus, I'm going to rewrite it as 5b, it makes me a little happier. 18 times 5, that's 90, plus 40, that's all equal to 0. I'll simplify a little bit here, and probably screw it up in the process. I'm going to start with that positive, so that's 165. Take away 90, that is 75, plus 5b, and that's equal to 0. I'll take away 75, and I get 5b is equal to negative 75, or b is negative 25. All right. So, question 4. This is where it all comes together. 4a. So we've got a polynomial, x cubed minus 2x squared minus 11x plus 12. We're going to list all x-intercepts and then sketch it. Okay, so step 1 is I'm going to use my rational zeros theorem. So I'm going to list all possible roots. Possible rational roots, I should say. So I'm going to think about all of the factors of 1, which are plus or minus 1, and all the factors of 12, which are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, and plus or minus 6, and plus or minus 12. Whew. And so all the possible roots are these numbers over these numbers, which actually are just these numbers in this case, because divide them by 1. So that means plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. Okay. So, step 2. Test roots using the factor theorem. Okay, so I'm going to start with trying p of 1 because it's the easiest one to plug in. It's going to give me 1 cubed, which is 1, minus 2, minus 11, plus 12. And hey, that equals 0. So therefore, I can make a conclusion about a factor. I can say x minus 1 is a factor of p of x. So what that means is I can say that x cubed minus 2x squared minus 11x plus 12 is really equal to x minus 1 times something. And to find that something, I'll need to use long division. So I'm going to divide this number by x minus 1 to find out what lives here. So x minus 1 is going to go into x cubed minus 2x squared minus 11x plus 12. I'm going to do this really quickly. X squared minus x cubed. You actually may be quicker than me at this. Maybe I'm not going to do that quickly. But I'm not going to explain all my steps here. But which means I'm probably going to make a mistake, as I'm liable to do. Minus x squared plus x, and we'll take those away. This gives us negative 12x plus 12. That's looking good. So x goes into negative 12. Negative 12. X plus 12. Take away. We get 0, so we get no factor. No remainder. Good. Because if we had remainder, then it would mean x minus 1 wasn't actually a factor. So what that really means, so therefore, x cubed minus 2x squared minus 11x plus 12 is really equal to x plus 1 times that, x squared minus x minus 12. I can go further. I can say that I can factor that as well. I can see two numbers that add to negative 1 but multiply to 12. There, x minus 4 and x plus 3. And there we have it. Okay, so then therefore the roots are x equals negative 1, 4, and negative 3, which were all possible rational roots. Okay, now we're not quite done. We're asked to sketch. So, okay. So test roots, and then we have step 3, which was long division. And step 4, factor further. And step 5 is we're going to sketch. Alright, so I know that I have roots at negative 3, negative 1, and 4. And I know this is a nice polynomial graph. So I'm just going to... Wait, hang on a second. Something's not right here. Something isn't right. Because I want to get a negative y-intercept. So what the heck did I do to screw this up? Because if I graph this as a normal polynomial, it should look something like this. But that gives me a negative y-intercept, but I know that I should get a positive y-intercept. So what gives? This happens to us all, by the way, guys. This is why I give you tests in the first place. Checks, strategies for testing. Why would, when I plug in 0 for x, it give me a... Did I write it down wrong? I didn't write it down wrong. So if I plug in 0 for y, it should give me a positive x. That's really bothering me. Do we have a kiss somewhere? We don't have a kiss anywhere. The heck am I missing? This is driving me crazy. I'm sorry, guys. I have to pull up Desmos to check with this because that just seems bizarre. Alright, y equals x power 3 minus 2x power 2 minus 11x plus 12. Got my roots. Oh, wait. Oh, stupid me. Yeah, okay, I figured it out. You probably already figured it out just by watching, I'm sure. I was just having a senior moment over here. Alright, where is